Hi, my name is Philip Gurma,
I'm Thomas Solis.
and our senior design project is the Ocean Cleanup Robot. So the concept for our senior design project is a boat, a small scale remote controlled boat that is able to collect floating debris in fresh waterways such as lakes, rivers, harbors, etc. Um, this boat is not designed to break up hard packed clumps of trash, mostly just floating debris such as water bottle and other plastics. The device is able to return to its base location where it drops off the trash it collects, as well as recharge itself with a solar powered hub. The boat is able to regulate the speed at which it travels, as well as the speed at which it picks up debris. So, say if debris gets stuck, it should be able to reverse and then forward the motor in order to correctly pick up the trash.
So jumping into the design, we chose to do a catamaran dual hull style boat. And this would be so that the debris collection could take place in between the two hulls. And the conveyor belt that picks up the debris would be continuously running so that as the boat travels, it's constantly picking up what's in front of it. And the collected debris is stored in a compartment in the back where as the boat backs into its docking location, where it recharges, it could also open the trash door to release the collected debris. The internal components are shown in the figure. The battery being the heaviest component is stored in the middle for balancing purposes, with the electronics compartment behind it and the motor assembly following that. And then the entire conveyor belt assembly is off of the battery and then in front of it. The conveyor belt is driven by a stepper motor next to the battery. And it drives a belt that turns shaft 1, which drives the conveyor belt, and then shaft 2 is free spinning. The conveyor belt's material will be a wire mesh, stainless steel wire mesh, for corrosion purposes, and then also to allow water to travel between it or through it. And then the motor assembly for the boat consists of a servo motor that drives a motor caddy that holds a waterproof brushless motor that turns a propeller. So the servo motor's purpose would just be to articulate the boat, and then the brushless motor would be to control the speed. To make sure that the boat floats, we did a buoyancy calculation that was based on Archimedes' principle. And we found that the density of the boat is less than the density of water, so it has to float. And then we also calculated the buoyant force that's created from a volume of the size of our boat. And we found that the boat produces 94 pounds of buoyant force. Another test that we did on the boat was an FEA of the frame that's made of this aluminum alloy, of which the specifications are in this table. The fixed supports were placed on the frame under where the two holes are, and then the loads for the internal components were placed on the 3 cross members. And then we also tested bearing loads for the shaft supports of the conveyor belt. The total deformation of the internal components we found was 5.5 times 10 to the negative 7 meters. And again, this is just the force of the components like the battery, the electronics, and the motor assembly. We tested the equivalent von Mises stress, and the percentage of that to the yield strength of the aluminum alloy we found to be 0.104%. And then this would be the directional deformation on the shaft supports, because these shaft supports that for the conveyor belt shafts are just these thin aluminum bars or flat bars. So we did this directional deformation test to see if they needed more support. And we found it to be low enough to where it didn't seem necessary.
So our conveyor belt, a mock-up design is seen as such. The components are a 12-volt battery, an Arduino, a stepper motor, and a stepper motor driver module, as well as power resistors. The conveyor belt consists of a permeable belt, as said before, and the functions are to be able to go in forward and reverse. And this design will be attached to the frame of the boat. And so the circuit for our conveyor belt is seen on the picture on the right. And we calculated the current to the circuit to be approximately 0.36 amps, considering a 12-volt battery and a 33 ohm resistance. Considering the motor resistance of the stepper motor is about 5 ohms, we reset the current to be about 0.32 amps when accounting for that. And so our total power requirements end up being about 4 watts, and so we can select our power resistors to be rated for 4 watts at 33 ohms. And so our power and battery requirements are based off the equation on the top, and we get about 560 watts or 3/4 of a horsepower. And so using those ratings, we can see we selected a max discharge current, or we calculated a max discharge current of about 140 amps. And so we selected a LiPo 6-cell 22.2 volt battery at 60 amps. And so we can see that the factors for increasing discharge is about 1.3, and the LiPo factor of safety is about 1.8. We get a C rating of about 30 Cs, which is a measurement of how fast the current can charge and discharge. And so the battery doesn't hold too much, or it discharges pretty fast, and so it gives us about like 2 minutes of battery time. But if we pack these batteries in series or parallel, we are able to get more life out, or more running time out of them. And so determining our motor requirements, we approximate the max unloading RPM of the motor to be about 26,000. And so we can calculate the kV value of the motor to be about 1,171 RPMs per volt. And using the wattage of the motor to be approximately 560 watts times a factor of 1.4, we get 784 watts. And using that, we can determine the motor size, dividing by 4.5. And we get approximately 174 grams, but to account for the weight that we're having on the boat, including components and debris and trash and whatnot, we selected a 600-gram motor, and which happens to be the one pictured below, which is a waterproof brushless and electronic speed control combo. And it's rated for our 6-cell 150 amp waterproof electronic speed controller. And it runs about 2,000 kV, which is slightly higher than what we calculated. Our radio controller uses a receiver and a transmitter to send and receive radio signals to control the motors. And so they're utilizing joystick modules where one controls a brushless motor, which is how fast our boat is going to be going, and the other controls a servo motor, which has our directional control. And so using a shaft that is connected to the servo motor and onto the platform of the brushless motor, we were able to have control over the angle at which the servo motor turns which determines whether the boat is turning left or right. And using the schematic below, we're able to utilize a pretty compact design and able to put it on the boat without any further weight added. And then these are our references to our pictures as well as some of the schematics, including the CAD models or the CAD uh, software used, as well as the ANSYS software that we use for the finite element analysis.